Welcome to the PicoBit-Tech channel. I'm Behnam Jafari, and in today's video series we'll focus on key concepts of the input and output C language that are essential for microcontroller programming. This is the second part of our Mastering Standard Input and Output in C series. We present 4 examples. Exercise 1, examining memory for a string variable. Exercise 2, using flags for formatting. Exercise 3, aligning strings on a single line. Exercise 4, using that precision for strings and floats. If you haven't watched the first video yet, I highly recommend starting in there. You can find the link at the top of the page. It covers the essential syntax and foundational concepts in detail. In this session, we will practice using printf function while also demonstrating effective debugging strategies in C programming. If you're ready, let's go. Exercise 1. Examining memory for a string variable. The general syntax of printf is shown below the screen. We will demonstrate how flags, widths, precision, and lengths work through practical coding examples. Each uppercase or lowercase English letter corresponds to a number stored in the computer or microcontroller's memory as binary data. The ASCII code table, which we briefly discussed in the last video, assigns decimal value to these characters. We'll define a string variable that occupies 12 memory spaces. This variable stores the string hello world, which consists of 11 characters, 10 letters plus a space. Additionally, the compiler appends a null character /0 at the end of the string to mark its termination. Therefore, the total allocated memory includes the 11 characters plus 1 space for the null character. In this exercise, we will examine the memory allocated to the string variable and demonstrate the effects of flag and widths. Each character in hello world corresponds to its ASCII code, starting from position 0 and ending at 10 in the string variable. To display these values sequentially, we'll use 11 printf statement, each printing one character of the string along with its ASCII value. The new line character or /n ensures each output appears on a new line. To include the null character, we will access the 11th memory spaces, which stores the value 0 in decimal form. The %d specifier in the printf statement ensures the variable is displayed as a decimal number. Adding widths, for example, %3d ensures numbers with fewer than 3 digits are left padded with spaces. For example, the number 72 will have 1 space on the left. And the number 0 will have 2 spaces. Exercise 2. Using flags for formatting. Instead of padding with spaces, we'll use the zero flag to add leading zeros to numbers. To display numbers in hexadecimal format, we will use the hash flag along with the X specifier. Exercise 3. Aligning strings on a single line. We will print two strings on a single line with spaces between them. Each string contains 11 characters, and by setting the width to 15, we'll create a 4 space gap between the two strings. To left align the string, we use the minus flags. Exercise 4. Using that precision for strings and floats. This exercise demonstrates how that precision works works with two variable types, string variables. Setting that precision to 6 limits the output to the first 6 characters of the string. Float variables. A float variable stores decimal numbers. It prints with 6 digits of precision. To improve accuracy, we will change the variable type to double. Using that precision, we can control the number of decimal places displayed. Finally, we will combine widths, flags, and precision to observe their effects on both string and float variables. The minus flag aligns the text to the left. The plus flag adds a plus sign for positive numbers. However, note that using the plus flag with strings results in a compiler warning. Debugging in Eclipse IDE. To debug the program, navigate to the Debug Configuration section. Select .exe, for example PicoBit.exe, then go to the Debugger tab. Browse and select the file gdb.exe from the directory. If gdb.exe is not installed, you can easily install it using msys2. Open msys2 and run the command shown on a screen. Press enter to begin the installation. A web link is provided in the video description. For a detailed guide to installing msys2 and MinGW, refer the video links at the top of the screen. Observing program execution in debug mode. In debug mode, you can observe how each line of code executes step by step. Use the step over button to execute lines on one by one. Check the Variables tab in Eclipse to view variable values and their memory addresses. For example, the string variable str_var and display both ASCII value and corresponding characters. The first memory location contains the hexadecimal address of the string variable, for example 0x5FFE8C. As you step through the program, observe how variable values are updated in memory. Debugging in an external console. To debug in an external console for better visibility, go to Debug Configurations, select .exe or PicoBit.exe and enable the Use External Console option under the Debugger tab. Arrange the Eclipse IDE and external console side by side. Use a step over to execute each line and view the output. For example, line 7, assign hello world to the string variable, including the null character. Line 8, assign a value to the float variable. Line 9, print the string hello world to the external console. And line 10, print the floating point value. To prevent the program from terminating immediately after execution, include an infinite loop by while 1. This keeps the program running until you manually stop it. Thank you for watching this video. In the next video, we'll cover more input and output functions in C language.